All right. If you didn't understand the power stuff that we did, we're going to talk about that again today.
Happy birthday, Miss Weber.
I already said that, Lauren, you're late.
Hold on, my mouse is being really weird. Come on. You got this.
Yeah. So Wednesday.
There we go. All right. Using tests wisely. So, how large a sample should researchers take when they plan to carry out a significance test? So the answer depends on three factors for how large of a sample: the significance level, the effect size, and the desired power of a test. So, first of all, the significance level. That's our alpha, right? So alpha is either 1%, 5%, 10%. So how much risk of a type 1 error do we want? Because we can get a type 1 error, and that type 1 error has the same probability as our significance level, right? So if it's a 5% significance level, then we have a 5% chance of getting a type 1 error. So how much risk of getting a type 1 error do we want? Rejecting the null hypothesis when it's actually true. If a type 1 error has serious consequences, we might opt for an alpha level of 1%. Otherwise, we should choose 5 or 10%. Recall that using a higher significance level would decrease a type 2 error probability and increase power. All right? So those are your things you got to weigh when you're deciding. Effect size. You need to know what that means, so I would write that down. Effect size is the difference between the null parameter value and the actual parameter value. So whatever your null is and whatever the truth is, that difference is called effect size. So how large a difference between those two is it important for us to detect? Okay. And then power. So they give you that value. It's a decimal value. Power is what chance do we want our study to have to detect a difference of the size that we think is important. So power detects a type 2 error. It's the probability of avoiding a type 2 error. All right, so oh my goodness. Wow. Hold on. Okay. Can a 6-month exercise program increase the total body bone mineral content, TBBMC, of young women? A team of researchers is planning a study to examine this question. The researchers would like to perform a test. So null hypothesis would be 0, no change, right? And the alternate would be an increase. So where mu is the true mean percent change in TBBMC due to the exercise program. To decide how many subjects they should include in their study, researchers begin by answering the 3 questions below. I don't know why it says above. Below. Number 1, so we want to look at our significance level. So our significance level, the research decide that they're going to do alpha equals 5%. And that's going to give us enough protection against declaring that the exercise program increases bone mineral content when it really doesn't. So a type 1 error. And number 2, we want to look at the effect size. So a mean increase in TBBMC of 1% is important to detect. So what our null value was, which was 0, and what the truth is, 1%, we want to be able to detect that that is actually significant, all right? And then power. The researchers want probability of at least 90%, so there's our power, that a test at the chosen significance level will reject the null hypothesis, as it should. So 90% chance of avoiding a type 2 error. So the null is 0 when the truth is actually 1. We're going to look at this lovely activity, which I think will help explain some of this. So if you guys go to page 590, so we can read through this, and I'll change these lovely things. All right, Zach, will you read the beginning of the activity?
In this activity, you will use the statistical power applet book website to determine the sample size needed for the exercise study of the sample. Based on the results of the previous study, researchers are willing to assume that the data activity period. We'll start by seeing whether before or not subject.
Cool. Kyle, will you read the next part? All right, so if our mean, our null hypothesis is 0, but the truth is 1 down here, our alternate hypothesis, we have a 5% significance level, so here's our probability of rejecting the null. Then we have a power of 0.8, all right? So what does that 0.8 mean? That's the probability of correctly avoiding a type 2 error, okay? All right, what's the next part say, Delaney? All right, so we have a 5%. If I change this to, wrong way, 10% right here. Oh, 0, 1, is that what it said to do? Okay, 1%. Cool. All right, so we made our alpha a lot smaller, right? So what happened to the power? Yeah, it was like 80%. Now it's like 57%, right? And so, yeah, this got a little less, so we have a better chance of avoiding a type 1 error right here, but not quite as good of a chance of avoiding a type 2 error. All right, so Cece, what's the next part say? All right, so we're back to our 80% power, and what happens when I can increase the sample size? What happened to the power? All right, so the power is better when I increase the sample size. All right, Charlie, what's the next part say? All right, so I'll just go to 35, and we've got 0.9. I know, weird. All right, so 35 gave us the high enough power that we wanted, so we would be able to determine what sample size we want if we use this lovely app. Adem, what's the next part say? I don't know. What part did you just read, Charlie? Okay. All right, so if I increase this to 1.5, what happens to my power? A lot stronger, right? So what is this called when I have a bigger difference between my null and my actual effect size? All right. So if you increase the effect size, what does that do to the power? Increases it. What else was I supposed to test? 0.8. So 0.8 is going to be less, right? Cool. Owen, what's the next part say? Oh, you don't have your book open? Oh, you got it? significance level, such as 1%, or even if you insist on 5% versus 10, then you have to take a large sample size. All right, so smaller significance level means you need a larger sample. If you insist on a higher power, such as 99 instead of 90, you will also need a larger sample. And at any significance level and desired power, detecting a small difference between null and alternative parameter values requires a larger sample than detecting a large difference. So there's two ways to increase power, and they like to ask you this a lot in the book. The two ways to increase power are, anybody know? Increase sample size or increase significance level, right? If you increase the significance level, that one on the top goes further left, which gives you more power, okay? Yes. All right, when large samples are available, even tiny deviations from the null hypothesis will be significant. So definitely better to use larger samples. However, sometimes that is more expensive, and it's difficult to get a large sample. And then we also have, if it's really practically important, okay? So let's read through something that's not practically important. So you can see maybe when you should just think about it, all right? So suppose we're testing a new antibacterial cream on a small cut made on the inner forearm. We know from previous research that with no medication, the mean healing time, defined as the time for the scab to fall off, is 7.6 days. The claim we want to test here is that formulation NS speeds up healing. So we use a 5% significance level. We do the whole procedure, good times, all right? And we get 250 kids. We get 7.5 days from our sample. Wow, right? 7.5 is our sample, but it takes 7.6 days. So we actually find that that's convincing evidence. We end up getting a p-value of 0.04. We even had a large sample. That was great. All right. And because 0.04 is less than 0.05, we reject the null, and we're like, yay, formulation NH reduces the average healing time. However, no one cares, because having your scab fall off 1/10 of a day sooner is no big deal. All right? So just think about the study. I don't know, yeah. I know, that's great, Malcolm. So statistical significance is not the same thing as practical importance, all right? So just because something is statistically or whatever significant doesn't mean it matters, all right? So the remedy for attaching too much importance to statistical significance is to pay attention to the actual data as well as the p-value. Plot your data, look at the outliers, yep, and see if it matters. All right, there you go.